Right, Chapter 8 is going to be working with right triangles along with introduction to some trigonometry. So we're going to start with section 8.1, which is going to work with right triangles and their altitudes. We're going to be looking at discovering what a geometric mean is and how to find that between two numbers. And then we're also going to be looking at the relationships between the altitudes of a right triangle. So let's start out by looking at a right triangle here of triangle ABC and drawn in altitude of BX. What's actually happening here is this is creating three similar triangles. And as I go and separate these triangles, hopefully you're able to see that, okay, these are similar to each other. Now from this, I can create three similarity statements. And if I were to rotate these around a little bit, hopefully you'd be able to see real carefully or closely what they are. And so triangle ABC is going to be similar to triangle AXB. Those are the sides and angles that correspond. And then it's also similar to triangle BXC. All of them here have right angles at angles X or B, so I need to just make sure all of those correspond, and then looking at the corresponding angles to go along with those. Then if I look at this triangle, and let's say we wanted to find out what the altitude was. If you're given the base of your triangle and you look at it straight down and you can break it up, you can easily find out what the altitude is. Again, I'm going to take these two triangles and I'm going to pull these apart because you're going to notice now that really triangle ABC doesn't really help me out at all. It's triangle ABX and BXC which really helps us. So I'm going to forget about triangle ABC here, and I'm just going to look at the bottom two triangles. And with this, we can set up a proportion and look at all of the corresponding sides between these two triangles. So we're just reviewing here what we did last chapter, chapter 7, working with all the similar triangles. And I'm trying to solve for BX or XB. I'm given AX and I'm given XC. I don't have AB and I do not have BC. So we're going to forget about that part. Here I've got 14 over Y is equal to Y over 3. Cross multiplying, I get Y times Y is equal to 14 times 3. When you take Y times Y, that gives us Y squared. And 14 times 3 is 42. To solve for y, we're going to take the square root of both sides. This would give me y is equal to plus or minus the square root of 42. Now with the plus or minus that's here, because you're working with the altitude of a triangle, we cannot have a negative altitude, so that's going to give us the positive square root of 42. We talked about also how to simplify radicals, and square root of 42 cannot be simplified, so we're going to leave it just as that. With all of this here, you'll notice that I took the square root of these two sides that I multiplied together. What that's called is the geometric mean. The geometric mean is a positive square root of the product of two numbers. So you can take any two numbers, multiply them together, take the square root of that, and you have the geometric mean. By looking at what we were doing in chapter 7 by cross multiplying, here I get x squared is equal to a times b. By taking the square root, that's our geometric mean. Finding the geometric of 5 and 45, I can take the square root of 5 times 45. That gives me the square root of 225, and that simplifies to 15. Geometric mean of 8 and 10, I'm going to multiply 8 times 10 and then take the square root of that. So I get the square root of 80. Now we talked about how to simplify radicals. The square root of 18 I could rewrite as the square root of 16 times the square root of 5. And the square root of 16 we should know is 4. And I do not know what the square root of 5 is, so I'm going to leave it as 4 square roots of 5. And those are geometric means. So when you're working with finding a geometric mean, what you're actually doing here is you're helping find the altitude. And the altitude that's showing here in triangle ABC is this value of BX. And when I look at the proportions or the corresponding sides that are created from the similarity statement, by solving for that altitude, really all I need here are these first two ratios. Cross multiply, I'm taking bx times xb, and that's equal to ax times xc. So once we multiply bx times xb, those two values are the same, so that's the same thing as saying bx squared is equal to ax times xc. And so the values of ax and xc, what we're doing here are the parts of the base. And with those, since I want to get rid of that square root, get rid of the square, I'm going to take the square root of both sides. And then our altitude is equal to the geometric mean of the two parts of our base. And that's what we're ideally trying to do here. So to show this in an example with some actual numbers to help make this hopefully a little bit more clear, I'm trying to find the altitude of triangle BRT. So we can see that that's the length of AT. My base that I have two lengths to it. I've got 27 and I have 6. I could sit here and set up similarity statements and create proportions if I wanted to, or just knowing the fact that the altitude is equal to the geometric mean of the two bases makes it a much easier problem for us to solve. So here I'm going to take my length of x, which is our altitude, is equal to the square root of 6 times 27. 6 times 27, or 6 times 27, sorry, is the square root of 162. And this right here can get broken up into the square root of 81 times the square root of 2. So I'm going to end up with 9 square roots of 2 for our altitude. In triangle MYT, I actually have the altitude that's given to me, and I want to figure out what the length of DT is. Well, I can set this up the same way, just looking at 12.7 this time equals the square root of 6 times x. To get rid of a square root, we're going to do the opposite, which means we're going to square both sides. Taking 12.7 and squaring it, that gives us 161.29 is equal to 6x. And if I divide both sides of our equation here by 6, we end up with x as an approximate value of 26.88. So there's two examples of how we can use our geometric mean. If you're not quite sure how that worked, pause the video, go back, rewind it before you move forward. Now this problem here, I'm not asked to find out what the altitude is. I'm trying to figure out what the other two sides of the right triangle are. There are two different ways of solving this. One way, we can use the geometric mean and find the altitude. The other one, we can use a relationship between the altitude here and the sides that we have. So first of all, option one, I'm going to look at that one, and that's using the fact that we need to find out what our altitude is. So that means I need to figure out what SQ is, and that's going to be the geometric mean of the base, which is the length of 4 and 2. So here I get the square root of 8, which can be simplified as the square root of 4 times the square root of 2, and I get 2 square roots of 2. So there's our altitude. Now what that's doing is it's creating two right triangles. And when we're trying to look at right triangles, we should know how to find the third side using the Pythagorean theorem. And my third side is actually the hypotenuse. So to set this up, I can take the value of 2 square roots of 2, square it, add 4 squared to it, and that's going to give us x squared. When you take 2 square roots of 2 and you square it, you're multiplying 2 square roots of 2 times 2 square roots of 2. What we talked about before this chapter in reviewing how to work with radicals, we take 2 times 2, which is 4. Square root of 2 times square root of 2 is a square root of 4. Here I'm going to get 4 times 2, and I end up with 8. So I'm going to take 8 plus 16 is equal to x squared. Well, 8 times 16, that gives us 24, equals x squared. And now I'm going to take the square root of both sides, and we get x is equal to the square root of 24, which can be simplified into square root of 4 times the square root of 6, and I get 2 square roots of 6 for our value of x. To find y, we're just going to set up a right triangle on the other side. I'm going to take 2 square roots of 2, again, my altitude, plus 2 squared equals y squared. 2 square roots of 2 squared, we talked about how that was already 8, plus 4 is equal to y squared. This gives me 12 equals y squared. Take the square root of both sides, and now I get y is equal to the square root of 12. Square root of 12 can be broken up into the square root of 4 times the square root of 3, and then I end up with 2 square roots of 3 to solve for y. So I'm using the geometric mean to find the altitude, and that's dividing this into 2 right triangles, allowing me to use the Pythagorean theorem to find the third side. Your second option for solving this problem is to look at the altitude relationship. Now this is a long drawn out sentence here. It says if the altitude is drawn from the vertex of a right angle of a right triangle to its hypotenuse, and that's what we're doing right here for the altitude, then the measure of a leg of the triangle is the geometric mean between the measures of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So we got all kinds of things going on here, and really what I think the best way to doing this here is just to show it to you with a little bit of color. And let me erase that. And looking at what I have here with the proportions that are given to us in the book as we look at this, I have AC corresponds with AB, AB corresponds with AX. Well, AB, those values are the same. We saw that in our previous example. And AB right here is going to then, I would get AB squared equals AC times AX. Taking the square root of it, that would tell me what AB is. AC is the length of the entire base, and AX is just part of that, and this is allowing us to find AB. So I'm going to go back up to this example that we just did and show you how to solve this a second way. This time what I'm going to do is I'm going to look at this value of x that I'm trying to find, and I'm going to look at the side opposite of it, which is this whole length of RP, and then with it I'm going to look at the length of RS. What this property is telling us is that the length of x is equal to the geometric mean of this whole side, which is 4 plus 2, which is 6, times 4. So if we take 6 times 4, that's going to end up giving us 24. And the square root of 24, we can look at that as the square root of 4 times the square root of 6, and so I get 2 square roots of 6, and that's what we get for x. Same thing that we got prior to this. If I wanted to figure out what the value of y is, this time, finding the value of y, I'm going to take the entire bottom length here of PR, and I'm going to look at just PS this time. So I'm going to take the geometric mean of the purple and the blue line. So we're going to look at y is equal to the square root of 6 times 2. So I get the square root of 12, which can be broken up into the square root of 4 times the square root of 3, and we get 2 square roots of 3 for y, and that's the same thing that we got before. Now, if you don't like solving it this way, go right ahead and use finding the altitude and working with right triangles. You have 2 different options for this problem. Just to kind of go through one more example of it, just to kind of clarify everything, we're going to want to find out this length of x. So we are going to take the geometric mean of the length of BC along with BD. So this is going to tell me that x is going to equal the square root. The whole length of BC gives us 16 multiply that by 2. Okay. And so now I get the square root of 32. And we can break that up into the square root of 16 times the square root of 2, leaving us with 4 square roots of 2 for our value of x. To find the value of y, we're going to take the entire length of BC, multiply that with the length of DC, and we're going to find the geometric mean then of those two sides, or those two values. So y is going to equal the square root of 14 times 16, gives us a square root of 224. Here we can break this up into the square root of 16 and the square root of 14. And so I would end up with 4 square roots of 14 for our value of y. So that concludes section 8.1, working with the geometric mean. What I'd like you to do for class is this next problem I would like you to bring with you. It's a right triangle, and I want you to solve for A, D, and V. So have this on a separate sheet of paper, something that will be able to be turned in. Do not leave it on your notes. Have it so that you can turn it in tomorrow at class.